Greetings to all the viewers. The session is going to cover with the intermediate chemistry will be fetching for your international entrance and the competitive exams. India is conducting JEE Advanced. JEE means examination all across India for the entrance into IIT and NIT stream, that is the technical domain. And a NEET exam will be conducted across India for medical entrance examination. Telangana and Andhra Pradesh government are conducting the entrance into the BTech stream by MSET conducting MSET examination. In addition to all this, competitive exams will be conducted by various government organization, government portals, where general studies common question paper will be there. General science content is available over there. The session what we are discussing is very much fetching for that kind of preparation. Let's enter into our today's session. The Nobel Prize in the field of chemistry for the year 1997 was divided one half jointly to the Paul D. Boyer and John E. Walker, these two scientists, for their elucidation of enzymatic mechanism underlying synthesis of adenosine triphosphate. ATP stands for adenosine triphosphate, and other half is given for Jens C. Skew for the first discovery of ion transporting enzyme, that is Na plus and K plus ATPase. Okay, both are related with the both the work related with the contemporary biological application field. Only ATP is more very profound material component which gives the energy. It is described as the energy source of living organisms. ATP is described as the energy source of living organism. It's a synthesis, underlying synthesis entire mechanism, what mechanism entire thing got evaluated and explored by the scientists together, so that they are recorded. And another scientist who also worked on the same kind of biological activity by ion transporting enzyme sodium positive potassium positive ATPase. So this is the way Nobel Prize in the field of chemistry for the year 1997 was accorded in the biological system exploration. Let's go with there. These three are the scientists who are accorded with the Nobel Prize for the year 1997, Paul D. Boyer and John E. Walker and Jens Kyo. Jens Kyo is another scientist. This is the way the award was given. Let's go with their brief info regarding this 1997 Nobel Prize laureates in the field of chemistry. The Royal Swedish Academy of the Sciences has decided to award 1997 Nobel Prize in the field of chemistry to the Professor Paul D. Boyer, University of California, Los Angeles, United States of America, and Dr. John E. Walker, Medical Research Council Laboratory of Molecular Biology, Cambridge, United Kingdom. For their elucidation of enzymatic mechanism underlying synthesis of adenosine triphosphate. Adenosine triphosphate is the energy source. Just we discussed about that one. So in that energy will be stored. So that kind of the how it is working and what is enzymatic action is there. Entire elucidation got carried by these two scientists together. And another is about Professor Jens C. Skov, Aarhus University, Denmark. He was accorded with the Nobel Prize for the first discovery of ion transporting enzyme sodium positive and potassium positive ATPase. So this is the kind of enzyme how the ion transportation is possible by means of this kind of mechanism got elucidated by the Jens Skov scientist. This is regarding the brief info, and we will enter into our discussion in detail. The three laureates have performed pioneering work on the enzymes that participate in a conversion of high energy compound adenosine triphosphate. So more or less all the work is revolving around this adenosine triphosphate only, right? How its synthesis, what mechanistic activities got carried, and what enzymatic activities taken place, entire thing laying around this adenosine triphosphate concept. Paul D. Boyer and John E. Walker received the Nobel Prize for their work on how the enzyme ATP synthase catalyzes the formation of ATP. How the enzymatic synthesis of adenosine triphosphate is possible, that was unveiled by these two scientists together. Boyer and his co-workers have given basis of biochemical data mechanism for how ATP is formed from the adenosine diphosphate. Adenosine diphosphate able able to combine with the inorganic phosphate so that triphosphate will be originated. Walker and his co-workers have established the structure of enzyme and verified the mechanism whichever given by the Boyer. Whatever assumption given by the Boyer, that a mechanistic part and the proof related entire concept was given by Walker, so that it is a kind of a collaborative work, we can say, so that they are together laureated with the Nobel Prize in the field of chemistry. Jensen Squier receives his half of the Nobel Prize discovery of enzyme sodium potassium stimulated adenosine triphosphate. So phosphatase, this is a kind of enzyme which used to pump the sodium and potassium ions. How that pumping is possible, transportation of these ions are possible all across the living organism. That kind of mechanism got unveiled by the scientist Jens C. Squier. This enzyme maintains the balance of sodium potassium ions in the living cells. Everybody aware that sodium potassium ions are required in the bulk quantity. It is not the trace quantity ion, rather these ions are the bulk quantity ions required in the optimum level, so that our entire organism's blood pressure got controlled over there. So that's the reason why sodium potassium ions levels are very important in the living organism. That balance is carried by the enzyme sodium potassium ATPase. Both the enzymes are bound to membranes in the cell and linked with the transport of the ions through, but for the different reasons. Right, so here membrane bound enzymes, these are. Let's go with the detailed explanation how the research got carried and why they are accorded with the Nobel Prize. ATP, a universal energy carrier in the living cell. ATP is acronym is adenosine triphosphate. So adenosine is the kind of what we can say, that is the DNA matter, and triphosphate, 3-phosphate units are present over there. So that ATP is considered as a universal energy carrier. The German chemist Karl Lohmann discovered ATP in the year 1929. Its structure was clarified some years later in the 1948 by Scottish Nobel laureate, 1950 Scottish Nobel laureate. 1957, Alexander Todd synthesized ATP chemically, right? This is the kind of collaborative work we can say. So how the ATP, what is adenosine triphosphate, what will be its chemical structure, and is it possible to synthesize the same compound in the laboratory? So that entire collaboration work got carried across the time period. An important role was that played by the 1953 Nobel laureate medicine Fritz Lippmann, when he during the years 1939 to 41 showed ATP is a universal carrier of chemical energy. ATP is able to carry the chemical energy into the cell and coined the expression energy rich phosphate bonds, right? So these phosphate bonds whichever present, these are called energy rich phosphate bonds. Here triphosphate means 3-phosphate units are linked with this DNA matter, so that all this kind of entire skeletal framework is regarded as a energy rich phosphate bonding. ATP functions as a carrier of energy in all living organisms, from bacteria, fungi to the plants and animals, including humans. So everywhere, wherever you can see the living organisms, in that wherever energy requirement, energy identity will be there, that is denoted with this adenosine triphosphate. Adenosine triphosphate captures chemical energy released by the combustion of the nutrients, transfer it into the reaction that requires energy, right? So whenever we are burning the log, what happens, it used to give the heat amount, that combustion giving rise to the energy, right? In the same manner, whatever food we are consuming inside, that will be burned in the presence of oxygen. Again, it is the process of combustion. The energy released can be stored in the form of these ATPs. The building up of the cell components, muscle contraction, transmission, nerve message, and many other functions are possible by means of these ATP and its activities only. ATP has been termed as a cell's energy currency. ATP is regarded as a cell energy currency. It is the kind of identity for the energy. We can denote it as the energy currency, right? So adenosine triphosphate ATP consists of a nucleoside. So it is a genetic matter, we can say adenosine, that is linked with three phosphate groups, right? So three phosphate moieties are linked up with this adenosine. The adenosine is the kind of purine pyrimidine base, and it is a nucleoside, we can say. On removal of the outermost phosphate group, adenosine diphosphate. One of the phosphate, if removed, what happens? It will be turned into ADP, so that energy will be released out. Okay, is formed, while at the same time energy released can be employed for other reactions. Okay, whenever we need energy in order to walk, in order to read, in order to sleep, everywhere we need some extent of energy that is released by these ATP molecules by liberating one of the phosphate, so that inorganic phosphate will be released and ADP will be generated. Again, it is a kind of repetition of the process. ADP further transformed biologically by enzymatic action. This is the way new energy generation and restoration is possible, right? Conversely, with the help of energy, an inorganic phosphate group can be bounded to ADP and forms the ATP. This is a kind of reversible process. Always restoration is possible. Otherwise, energy balance will become a difficult one. So, if ATP is not restored that extent, what happens? Energy imbalance is possible. We are not able to do whatever we have to do. Right. Considerable quantities of the ATP are formed and consumed at rest. An adult converts daily a quantity of ATP corresponds to about 1/2 of body weight. Okay. So how extent we are consuming these ATPs? So quantity of ATP required is 1/2 of the body weight. For example, body weight is 40. So the 20 ATP units to be consumed per a day. This is the way a kind of calculation, and this is for the adult human, we can say. Right. And during the hard work, the quantity can be raised to almost a ton. Okay. So if the person is doing maximum extent of work, so that consumption of ATP also increased exponentially at that extent only, right? Most of the ATP synthesis is carried out by the enzyme ATP synthase. Okay, in order to convert ADP into ATP, we need to get the support with ATP synthase enzyme. ATP synthase used to transform that ADP, adenosine diphosphate, into adenosine triphosphate at rest. Sodium potassium ATPase uses up a third of all ATP formed. Right. So here, finally, ATP molecules will be generated by consuming this kind of enzymes, and so many chemical transformations are carried over. ATP synthase, an exceptional molecular machine. ATP synthase. Why we are saying a molecular machine? Because immediately it used to restore that ATP, how much it is required by the living organism. During 1940s and 50s, it was clarified that bulk of ATP is formed in the cell respiration. Right. ATP is formed by the respiration. What relation between the respiration and ATP generation? Because ATP, as already we aware, just now we quoted that it is the energy currency. ATP is regarded as the energy currency. Then respiration is the process absorbing that means inhaling oxygen and exhaling carbon dioxide. This is the way respiration process carried. Then what relation between ATP and respiration? Respiration used to induce the oxygen inside. Whenever oxygen is going inside, that oxygen used for the combustion of all the food materials whichever present. Whenever food got combusted, that means food got burned, we can say digestion process. Upon digestion, the energy released can be stored in the form of these ATPs. This is energy currency, we can say. So that cell respiration and ATP is directly related, and these ATPs are stored in mitochondria, so that we can say mitochondria are the powerhouse of ATP. Right. Photosynthesis in the chloroplast of the plants. So what way for photosynthesis and ATP related again? Photosynthesis is the mechanism where Carbon dioxide and water get combined in the presence of sunlight and the chloroplast, so that kind of inorganic materials got converted into organic carbohydrates. That is the energy source. This is the way generation of energy is possible in multiple steps. Whatever nutrients generated by this photosynthesis, later on combustion by means of this respiration oxygen, they got transformed into energy, can be stored in this ATP, right? In 1960, American scientist Ephraim Racker and co-workers isolated from mitochondria the enzyme, if not F1 ATPase, which we now call it as ATP synthase. Okay, so here the first ATP synthase enzyme was isolated in the year 1960 by the American scientist. Who is that? Ephraim Racker. Ephraim Racker and his co-scientist worked upon this isolation of this ATP synthase enzyme, so that later on it got renamed as, if not F1 ATPase, so that it is the key enzyme which used to convert ADP into ATP, which is the energy currency, we can say, right? The enzyme can be divided into F1 part containing catalytic center and F0 part coupling, F0 part of the membrane. Okay, so as already we aware, the enzymes whichever present here, which are membrane bounded enzymes. So this is the way membrane bounding is possible. The same enzyme exists in a chloroplast in bacteria as well. Whatever enzyme is present in the all living organism, being complex living organisms present, and simplest bacteria, in that also how well the development got carried for these type of ATP synthase and these enzymatic function, the same manner, or even bacteria also having same kind of activity, right? In the year 1961, Peter Mitchell presented what is termed the chemiosmotic hypothesis. Let me repeat, chemiosmotic hypothesis, for which he received the Nobel Prize in the year 1978. Okay, so this is another new concept we can say, chemiosmotic hypothesis. He showed that cell respiration leads to the difference in the hydrogen ion concentration, right? So respiration, so individual cells also possible to absorb the oxygen and excrete the carbon dioxide. Then only whenever oxygen is transported through the bloodstream in the entire body, what happens, individual cells are used to absorb that oxygen, right? At the same time, whatever carbon dioxide generated get released, so that we can say even as individual cell is able to respirate. So that's the reason why bulk quantity of carbon dioxide got collected back by the bloodstream whenever it is returning back, and shifted and pumped to the heart, and heart to the lungs to the exhalation process. This is the way entire process got carried every fraction of second, we can say. So that cell respiration is also possible, right? So leads to the difference in the hydrogen ion concentration. Whenever this cell respiration process got carried, what happens? Hydrogen ion, H plus ion concentration got varied, which changes the pH level. The cell pH will be varied in and out of the mitochondrial membrane. So because of this, the natural process called respiration. That stream of hydrogen ion drives the formation of ATP. Whatever hydrogen ion concentration got varied, got changed, that stream of hydrogen ions, which used to synthesize this adenosine triphosphate. The same applies to the chloroplast membrane again. The coupling of ATP synthase to the hydrogen ion transport takes place via the F0 part. This is the way ATP synthase is the kind of enzyme, key enzyme we can say, are exceptional molecular machine in order to synthesize this energy device, energy identity called ATP. This is the way the entire work got carried by these three scientists together on this ATP synthesis mechanism and pathway, how the enzymatic work is going on in order to synthesize ATP, as well as sodium potassium ATPase enzymatic work, that is ion transportation work, is also unveiled by these three scientists together. So that 1997 Chemistry Nobel Prize was accorded for these three eminent scientists, which is a world recognition. Let's go with this. Question number 2, which is collected from the Cambridge Assessment International Education. This question is about acids and bases. Describe the color of the methyl orange in acidic and alkaline solution. In acidic solution, what will be the color? Alkaline solution, what will be the color? First of all, we have to know methyl orange is the kind of indicator. What is the role of indicator and why indicator is used? Indicator is very essential in the titrations. What is meant by titration? Mixing of titrant with a titrate in order to unveil, in order to identify concentration of unknown solution by mixing with known concentrated solution. Then, whenever concentration is identified, what is the role of this indicator? Indicator used to visualize the completion of the reaction, which is said to be equivalent point. So that whenever acid base, the topic is purely related with acid base. Whenever we are mixing with acid by titrating against base, for example, at that condition, what happens here? Environment initially acidic. Whenever base is slowly added, environment slowly turning into a basic one. So the indicator is the kind of chemical component. In the acidic medium, one type of chemical structure will be there. Upon converting into the basic medium, a slight transformation itself, it will rearranged into another, so that color transition we can notice. That's the reason why, though it is the same compound, it exists in acidic, one color in the acidic solution, in either colored in the alkaline solution. This is the way methyl orange. Methyl orange, acidic and alkaline solution colors to be mentioned. Go with the question number B. Complete the word equation for the reaction. Hydrochloric acid reacting with the calcium oxide. Hydrochloric acid is said to be a strong acid, and calcium oxide is the kind of strong base. Basic oxide it will be. Metal oxides, generally metal oxides are basic in nature. Non-metal oxides are acidic in nature. Amphoteric oxides, metalloid oxides are amphoteric in nature. This is the kind of elucidation of nature of oxides. Always metal oxides are basic. Always non-metal oxides are acidic. Metalloid oxides are amphoteric. Amphoteric means slight extent of acidic nature, slight extent of basic nature will be there. Being it is the metal oxide, calcium oxide is the metal oxide, we can say basic oxide. Hydrochloric acid is the mineral acid, stronger one. So whenever they got combined, so obviously there is a formation of salt and water. Let's see how can we complete the reaction. First of all, let me go with the methyl orange. Methyl orange is the kind of chemical indicator which used to identify substances basic or acidic one. So simply we can indicate it as a MEO, methyl orange. This is the kind of abbreviation. Methyl orange, a popular indicator in the titration process. During the titration, different colors are different pH values. Methyl orange is a kind of basic substance. It's found in yellow color in the unionized form. Whenever unionized is there, that existing in yellow color. And it turns a pinkish red color whenever medium turns to acidic. So that we can identify that yellow exists in basic medium and pinkish red appears in the acidic medium. It is used in labs and industries as a pH indicator, right? So wherever it is required, pH indicator, that means acidic conditions existing in the form of pinkish red and basic conditions yellow color, so that by changing pH color of the medium, color of the indicator will be changed. This is the way methyl orange used to work, and the color is only to be the answer for this question A. Let's go with this balanced word equation. In order to get the balanced word equation, calcium oxide can be treated with hydrochloric acid. The expected products are calcium chloride and water. So as already we are aware, whenever acid-base treatment is possible, salt and water will be generated. So that here we can write it as calcium chloride. So here, being it is a word equation, we have to write it as a calcium chloride. And here we have to mention water. So always acid-base reaction giving rise to the salt and water, so that here calcium chloride is a salt, water is also generated. By this, we conclude this question number 2. Let's move with question number 3. Question number 3 collected from 2015 JEE Advanced Paper 1 question paper, National Testing Agency conducted this exam. For the octahedral complexes, Fe plus 3 in SCN minus thiocyanate S and Cn minus ligand environments, the difference between the spin-only magnetic moment in the Bohr magnetons when approximated to the nearest integer is atomic number of iron is 26. Let me repeat the question. Here the complex must be octahedral. That is made up of iron at the central core and the set of ligands are SCN minus or else Cn minus. So once we can prepare the entire iron complex, octahedral complex with the 6 ligands of thiocyanate and 6 ligands of cyano as well. So this is the way two different complexes we are going to build up. Whenever these two complexes, iron thiocyanate, hexathiocyanato, iron hexacyano, two different complexes are there. Whenever these two are the condition, these two are the octahedral complexes, we have to go for the spin-only magnetic moment calculation. Spin-only magnetic moment is calculated by taking under root n into n plus 2 formula, and the values are mentioned in the Bohr magnetons. Okay. So in order to get this, atomic number is provided as 26 for iron atom. Okay, how can we solve this one? In order to get this, Fe plus 3 is the kind of that 3D series it will be, and here you can notice whenever 3 electrons got lost, 3D 5 electronic system will be their outer electronic configuration for iron plus 3. Sn minus cyanide is the ligand which is said to be strong field ligand over there. It produces low spin complex. Whenever Cn is there, strong field always giving rise to the low spin complexes. Low spin is nothing but whatever electrons are present. How many are there? We can notice only 5 electrons. All 5 electrons got having tendency to pair up. But 5 electrons odd number, that's why 4 electrons got paired and 1 odd electron still remains over there. So low spin always giving rise to the pairing of electrons under strong field ligand. Okay, so at that condition, one unpaired electron is located. In order to calculate spin-only magnetic moment, mu effective is equal to root of n into n plus 2 can be taken. Root of n denotes number of unpaired electrons. How many unpaired electrons we can locate? Only one unpaired. So that root of 1 into 1 plus 2. So 1 plus 2 is called 3. 3 into 1, 3 itself. Root of 3 is nothing but 1.73 Bohr magnetons. This is the value given for hexacyano iron plus 3 octahedral complex. Hexacyano iron plus 3 octahedral complex whose spin-only magnetic moment value is calculated as 1.73 Bohr magnetons. Let's go with thiocyanate. So compared to thiocyanate is the weak field ligand, so that it produces high spin complex. High spin is nothing but whatever 5 electrons are there. Upon octahedral splitting, 3 electrons laying in a T2g orbital and 2 electrons are jumped into EG orbital, so that 5 unpaired electrons are present. All 5 unpaired electrons contributing their magnetic moment, so that we can count all 5 electrons for this mu effective value, spin-only magnetic moment given by root of n into n plus 2. N value is nothing but number of unpaired electrons. You can notice 5 unpaired electrons, so that 5 multiplied with 5 plus 2. So that 5 plus 2 is nothing but 7. 7 5s are 35. So root of 35, the value calculated as 5.92 Bohr magnetons. But the question is, the difference between the spin-only magnetic moments, difference to be calculated. In order to calculate the difference, higher value minus lower value. Higher is 5.92, lower is 1.73. So that the difference is calculated as 4.19 Bohr magnetons. When we round up, it will become 4 Bohr magnetons. 4 Bohr magnetons is the difference between the spin-only magnetic moment values whenever the two different complexes made by iron with thiocyanate one time and iron with the cyanide with another time. Both are octahedral complexes only. This is the way we can go with the calculation, and this is the way electron distribution is described for this octahedral complex of iron plus 3, which is the D5 electronic system. By this, we can conclude the question number 3. Let's move up with question number 4. It is also collected from 2000. 15. JEE Advanced Paper 1 question paper conducted by National Testing Agency. All the energy released from the reaction X tends to giving Y, and delta G naught is equal to negative 193 kilojoules per mole is used for oxidizing M plus into M plus 3. Whenever M plus turned into M plus 3, obviously 2 electrons will be removed. Then E naught. E naught means standard electrode potential value is given by negative 0.25 volts. Under standard conditions, the number of moles of M plus oxidized when 1 mole of X is converted into Y is, right? Under standard condition, the number of moles of M plus oxidized when 1 mole of X is converted into Y is 1 Faraday of energy is given by 96,500 coulombs per mole. So this is the problem collected from where? It is the problem purely related with the electrochemistry and the thermodynamics together, because we have a Gibbs free energy value, we have standard electrode potential value as well. So that it is laying in the physical chemistry part where thermodynamics and electrochemistry plays a role. Let's see. Here is the chemical equation where oxidation process got carried. M plus monopositive metal was taken, tends to release 2 electrons and converted into tripositive metal. Okay. N number. So this is for 1 mole. So if N number of moles of monopositive metal ions are present, they are able to release 2N number of electrons, because 2 electrons released per 1 metal, right? Then 2N number of electrons released per N number of metals, so that N number of tripositive metal ions will be generated. Whenever N number of metal ions got oxidized, that Gibbs free energy, standard Gibbs free energy, we have to say. Delta G naught is nothing but standard Gibbs free energy change. Okay. Standard Gibbs free energy change is described as minus 2N Fe naught. N is nothing but what? Number of moles. F is a Faraday. Faraday value is also known to you. And E naught is nothing but standard electrode potential in volts, right? So if this is the formula, if we substitute all the known terms in this, obviously we can calculate whatever required. Delta R G naught. Delta R G naught is equal to delta G naught. Right. So here all the energy released for this one under this, the number of moles M plus oxidized when 1 mole is converted into Y is, the standard condition, number of moles of M plus. How many number of moles? So number of moles to be calculated. Here the requirement is the calculation of N value to be identified, so that here delta G value is known to you, that is delta G value is provided 193 kilojoules mentioned, so that let me convert into joules, kilojoules to joules, so that 193 multiplied with 1000. Okay, so that is equal to minus of 2N Fe naught. 2 can be taken as such. So here 193 is given with the negative sign, right? 193 is having negative sign convention. If you put negative sign convention here also we have negative sign convention for the equation, that is the minus of 2N Faraday and E naught, so that negative sign right and left both got compensated. We can cancel out. So that is the way negative charge got cancelled out. Okay. So here delta G naught value is 193. Kilojoules to joules conversion 1000. And here negative sign we compensated just now. 2 remains as just being it is an integer, let me put as such N value to be calculated. So that let me put N like this, and Faraday which is given 96,500 coulombs, so that let me mention 96,500 coulombs. E naught is the standard electrode potential value, which is given as negative of 0.25 volts. So that 0.25 volts is there. Okay, all the integer values are known except N. So if you go with the calculation of N, after the entire calculation, we will get N value as a 4. So this is the way number of moles for the conversion of M plus into M plus 3 is calculated as 4 moles are required. Okay, by this statistical data, 4 moles are required over there. This is the way question 4 can be answered. Let's go with the question number 5. Question number 5 collected from Telangana IMSET 2020 question paper. Let's assume C1 is equal to C2. Bond in the acetylene. So it is not C1 is equal to C2. It is the C triple bond C. Being it is the acetylene, we can go with acetylene is composed by 2 carbon atoms only. C triple bond C bond in the acetylene is along Z axis. Okay, always acetylene or any triple bond taken, that is linear only. That linear bond is oriented towards the Z axis. Find out correct combination of atomic orbitals with non-zero overlapping. So here how the atomic orbitals are combining with non-zero overlapping. Acetylene loni C1 triple bond C2 బంధము X అక్షంలో ఉన్నదిగా ఊహింపుము. అశూన్యత అతిపాతం గల పరమాణు ఆర్బిటాల్ల కలయిక ఏదో కనుక్కోనండి. ఓకే, అటామిక్ ఆర్బిటాల్ కాంబినేషన్ టు బి డిపెక్టెడ్. ఓకే, in order to get that one, everybody should aware that carbon carbon triple bond must be a linear one and they are laying on the Z axis. If that is the case, so that same conditions to be taken into the consideration. Let's go with one by one option. 2px of C1, 2py of C2. So whenever we are taking x-axis and y-axis and they are not laying on the same linear page, right? So that we can cancel out. 2px, 2py not laying on the same axis. It will not give the linear structure of acetylene. So cancel out. 2pz of C1, 2py of C2. Again here z-axis is another coordinate. All three x, y, z3 are laying on the planar geometry. One is towards the x direction, in either y direction, z is towards the upper direction. If we assume, so if 2pz of 1 C1, 2py of C2, there is no way for that overlapping in order to get the linear triple bond, so that you can strike off option 2 as well. Go with the 2px of C1 and 2s orbital of C2. This is not yet all possible because acetylene is completely hybridized carbons only. C1 carbon is sp hybridized, even C2 carbon is also sp hybridized. So that how can we go with this 2s orbital? Always hybridized orbitals giving rise to the sigma bond, right? Later on, pi orbitals will be formed by lateral overlapping of unhybridized p orbitals only, but the 2s orbital will not come into the picture over here. This will not be a correct answer. Let's go with 2pz of C1 and 2pz of C2. This is perfectly correct because 2pz means both the orbitals are laying on the same axis. So that linearity, extent of overlapping is possible and extent of bond formation is also possible when two orbitals are laying on the same direction. So this is the way we can answer. So by seeing only we can easily trace out which is the correct answer. Right, for question 5, option 4 is the answer. Let's go with the detailed explanation. Acetylene is nothing but 2 carbons triple bonded. One is called acetylene. 2pz of C1 and 2pz of C2 along Z axis, because both the orbitals, p orbitals are in the same direction. Both are in the Z direction only, so that extent of overlapping and a linear bond formation is possible. So that acetylene is given like this, CH triple bond CH. This is only the allowed type of hybrid what a bond formation. So this is the way for question 5, option 4 will be the right answer. Let's go with the last question for the session, that is question number 6. With reference to the redox properties of hydrogen peroxide, which of these reactions are feasible? Redox properties of hydrogen peroxide means hydrogen peroxide is having the tendency to reduce the other substance and oxidize the other substance as well. Being it is a redox one, if another oxidizing agent is there, it will reduce. It will what it will do? It will oxidize. If reducing agent there, it will reduce. So that both the properties are possible. It is able to reduce the other thing, oxidize the other thing as well. That depends upon the nature of second one. Hydrogen peroxide is the redox reagent. Redox means Both the activities are possible. Oxidizing nature, oxidizing power is there, reducing power is also there. So that hydrogen peroxide is applied in the multiple applications, right? So in context to the redox nature, we have to trace out which are possible from the given equations. Whenever Fe+2 was taken, H plus was mixed up and hydrogen peroxide also added over there. Fe+2 got shifted into Fe+3 and H plus now converted. H plus is combined with hydrogen peroxide and is converted into water molecule. In this condition, Fe+2 turned into Fe+3, right? This is called oxidation. Obviously, H2O2 will be reduced. How can we say reduced? H2O2 is having two oxygens, but H2O is having only one oxygen. Descending or decreasing the number of oxygens also called a reduction rate. So that hydrogen peroxide got reduced, Fe+2 got oxidized. So that there is a redox reaction. And in this context, here hydrogen peroxide acting like a oxidizing agent, where it used to oxidize Fe+2 into Fe+3, so that it is the oxidizing agent. Let's go with another reaction where CaMnO4 or MnO4 minus. MnO4 minus is called manganate anion. Can be treated with 6 H plus ions and 5 moles of hydrogen peroxide. Whenever these are treated, MnO4 minus, where manganese is in +7 oxidation state, that will be turned into Mn+2. Mn+2 will be possible, and in addition H2O2, that is called water, will be generated 8 moles. Later on 5 moles of oxygen generated. At this condition, what we can say, which is oxidized, which is reduced? If you go with +7 to +2, +7 turned into +2 is nothing but what? Decrease in the oxidation state called reduction. Whenever it got reduced, so that we can say hydrogen peroxide got oxidized. And in case of Fe+2 turned into Fe+3, H2O2 turned into OH minus. So Fe+2 is converted into Fe+3. This is called oxidation. And CaMnO4 here, we can say +7 is there, and here MnO3 will be there. MnO2 will be there. +4 is possible. MnO2, +7 to +4 is possible. So that here also, what we can say, reduction process. So that under two conditions it is oxidizing, under two conditions it is reducing. So that obviously we can conclude redox properties are possible. All these are the category, all these 4 reactions belongs to the category of redox properties. So 1, 2, 3, 4 are correct answers. Let's see. Redox reaction is nothing but in which one of the substance will be oxidized and either substance will be reduced simultaneously. And hydrogen peroxide having dual nature, which used to oxidize and reduce other substances as well. So that in explanation to this one, all 4 reactions are following redox reaction, and where in 2 reactions hydrogen peroxide is oxidizing, in either 2 reactions itself it is reducing. Let's go with the clear explanation. Whenever H2O2, H plus and electrons, the formation of water is possible in the first reaction. So that we can say it is a consuming electrons. Whenever electrons got consumed, that is called reduction process. Hydrogen peroxide got reduced. And even H2O2, 2 electrons got consumed, hydroxide will be generated. That hydroxide generated, electrons consumed, reduction only. So that we can say these two are called itself it is reducing, so that working like a oxidizing agent. Whenever the substance is reducing itself, it acting like a oxidizing agent. So that in both the reactions, oxidizing agent. Go with hydrogen peroxide if it is releasing H plus oxygen and 2 electrons. When 2 electrons released over there, whenever 2 electrons released in the reaction, that is a kind of oxidation. Whenever the substance is oxidizing itself, it acts like a reducing agent. It will reduce others. It will be oxidized. It will reduce other substances. So that this is the way some cases it will be oxidizing agent, some cases it will be a reducing agent, so that we can say redox properties that are proven in all four reactions, so that we can put the tick mark for all four chemical equations. This is the way we got concluded with the various dimensions of chemistry. We covered with the various segments of chemistry, and really it will be interesting session if the people are more curious about the chemistry and its related application part. And the information collected from the various authentic sources and the previous repeated exam question paper was taken into the consideration. I'm sincerely requesting to like the channel and comment. In order to comment, we have a question for the session. So here commenting question will be there. Can you please put the definitions of amphoteric compound, acidic compound, basic compound? Just definitions are required to be posted for the session in this comment box. What is amphoteric? What is meant by amphoteric? What is meant by acidic? What is meant by basic? Acidic, basic definitions are given by different scientists in different ways. Any kind of scientist related definition you can quote over. Whatever you know, that kind of concept you can take, either Arrhenius, Bronsted, Lewis, whatever the concept you know, that kind of concept you can place. So according to Lewis, what will be the nature of, what will be the definition of acid? In that way you can put over there. This is the way what is meant by amphoteric substance, acidic substance, basic substance. These to be posted in this comment box and shared with the aspirants who are more serious about the examinations. And I will assure for that those who are seriously following the session, they will definitely achieve whatever they are aspiring for. And subscribe the channel. Definitely we will come up with the new content in the near future. Thank you one and all.